Hi everyone, my name is Berk and I'm recording this video to talk about my project. I did this project for my lecture EEE474 Foundations of Magnetic Resonance Imaging. As my project, I tried to examine the effects of B0 and B1 magnetic fields and also T1 and T2 relaxation times on the magnetization vector. So, as you can see, the relationship between B0 and M0 is pretty linear. And for B1, B1 is applied in the transverse plane, so the strength and duration of B1 determines the excitation angle. In order to examine the effects of T1 and T2 relaxation times, I had to simulate the Bloch equation. And in order to simulate the Bloch equation, I did some coding in MATLAB. So here's the main function. Here is the relaxation function. Here are two different rotation functions. In the main function, you can give arbitrary inputs to excitation and T1 and T2 and observe the effects. Before we have a sample run, let me talk about the functions and how they work a little bit. So, like I said, we have two rotation functions. The first one is to rotate any point about the x, y, or z axis with any given angle. The second one is to rotate the point about any given axis at any given angle. This is the function that simulates the relaxation effects. You can see that it plots out two different figures. And this is the main function, where you can utilize these functions to create arbitrary inputs and see how they work. Okay, let's have a sample run. Here you can see some excitations done on different axes. Here is the initial magnetization. We assume that it is in the z direction. We use the rotation functions to simulate excitations onto different axes. Here you can see the rotate 2 function exciting the magnetization onto transverse plane, but not on x or y axis. Okay, now let's simulate the relaxation process with T1 equals 500 milliseconds and T2 equals 100 milliseconds. You can see that we have two graphs, one on the left and one on the right. The graph on the left illustrates the components of the magnetization vector versus time, mx, my, and mz. The graph on the right illustrates mx versus my. On the left, you can see that the mz is gradually increasing, while mx and my are gradually decreasing. And on the right, you can see the precession movement of the magnetization vector. Now let's examine the effects of changing T1 and T2 on the magnetization vector. As you can see, while keeping T2 constant, we are giving different values to T1. And you can see that the precision movement on the right is kept constant, while the rate of increase in mz is different. And as T1 decreases, the mz recovery becomes faster. Now let's talk about the effects of T2. While keeping T1 constant, when you change T2, you can observe the effects on the precession movement on the right. Notice that as T2 gets larger, the precession movement becomes longer as well.